Detecting and responding to threats in the cloud is harder than doing it on-prem. Even when you do have the visibility you need, legacy security workflows weren't designed for the speed and complexity of cloud environments. Cloud-native security solutions from ExtraHop are purpose-built to spot threats across the hybrid attack surface, provide detailed investigation steps, and help you automate response. Request your 30-day free trial at securityweekly.com/ExtraHop. You want to get the right things done for your security program. Sounds simple, but what are the right things for you? What does done mean? And how are you going to get there? Rapid7 realizes more than anyone how hard this can be. While Rapid7's Insight platform offers you industry-leading vulnerability management and detection and response solutions, their focus is on understanding where you are so that they can help you get where you're going. Visit securityweekly.com/Rapid7 to get started. Welcome back, everyone, to Enterprise Security Weekly. Our next webcast is tomorrow, actually, with ExtraHop, talking about how to collect packets and do packet capture in the cloud. You can go to securityweekly.com, click that webcast drop-down menu, and register for that.
Yes,
which, I mean,
we're gonna have fun.
You should do
Jeff,
that
you
soon.
can't give away too much information.
That's right.
Right,
Jeff Deininger is here with us. He's a principal sales engineer at ExtraHop. Jeff, welcome to the program.
It's good to be here.
Jeff, I wanted to start by talking about how mature your cloud programs are in your respective or the organizations we work with, right? I try to gauge where some of our audience might be through some Twitter polls and other surveys, right? But you work hand in hand with customers. What are some of the different maturity levels that you've seen with cloud adoption, and how? What's the security paradigm like in each one of those phases?
Yeah, fantastic question. It's a great place to level set. So, and broadly speaking, we can say that there's really two types of organizations: those that are already in the cloud and those that are on their way. So, I think everyone understands the importance of cloud for agility, enabling the business to experiment, but also focus on its core competency and not do things like run mailbox servers or run directory servers, run infrastructure, period. And so really, if you look at the typical cloud adoption curve, first you'll see organizations adopting SaaS services, right? So that's really the easiest place to dip your toe in the water. And there's a set of security concerns and considerations around SaaS and how you protect data in a SaaS environment. After that, you're really looking at seeing adoption around infrastructure as a service. Finally, moving into serverless technologies, so function as a service. Platform as a service in a lot of ways goes hand in hand with IaaS, and so those are typically the milestones, if you will.
Right, and then there's like a million ways to put all those pieces together.
Right. Yeah, there certainly are. I mean, this is not a linear path necessarily. So you can certainly have organizations that are born in the cloud that start there and start with serverless. We see for traditional enterprises that are terrestrial, if you will, that are in running data centers or have their servers in co-location facilities. The typical path is let's move those workloads into the cloud, first into IaaS, and then as we start to build some muscle around service delivery and we develop some comfort around what our new attack surface looks like, then we start to refactor those traditional multi-tier applications into more of a microservices architecture.
Yeah, and I think one of the things I talk a lot about with analysts, because I do a lot of analyst calls, is, in the early days of cloud adoption, it was I took a server and I moved it to the cloud as a dedicated EC2 instance, kind of a one-to-one relationship. What I'm starting to see, and I'm curious on this, where we are kind of in this maturity curve, is what I'm starting to see now is that still happens, but then what you start to see is when people really understand the different services that are being offered by the cloud platforms, and Amazon and Microsoft both have exploded the number of service offerings, and even Google as well. But those are kind of the two biggies. You're starting to see a move away from dedicated EC2 instances, for example, into more platform types of services, which creates a really interesting challenge, I think, for the industry in some respects, because a lot of us really focused our early days of security around the network and the endpoint. And as you abstract away parts of the endpoint into these platforms as a services, the techniques we have to use to secure these new platforms are different. And as that migration continues, it creates new challenges for us, and probably new ways and new techniques. How much of that adoption from like what I would call cloud adoption phase 1 to now this kind of phase 2 of people moving into platform as a service?
Yeah, so from what we're seeing at ExtraHop, the serverless is absolutely here to stay. I mean, it's been around now for 5 years or so, and it's becoming mainstream certainly. But I'll still say there are, for a number of organizations, particularly the the Fortune 500, kind of Fortune 1000, Global 2000 market segment. You have this split where the super mature shops are all in, and they are maybe even a majority of their services are running on serverless. But then we also see, a lot of those organizations can be slow to change. They're supporting legacy applications that they've had for a number of years, and so there's still, I would say, a preponderance of EC2 based workloads as well. And so, whereas serverless is more aspirational or more of a roadmap item for those organizations.
Got it.
Well, yeah, because you have to rewrite potentially your entire app, at least a significant portion, to get it from running on a legacy server to running it in a serverless
kind
or
of
utilizing
a
services.
crawl, walk, run kind of scenario, right? You got to kind of get the basics down, get your delivery models down, then you're ready to go to more of these advanced services. But I think over the next 3 to 5 years, we're going to see more of that shift into these more serverless type platforms, which I think as that accelerates, it just creates some really interesting challenges in the industry.
Yeah, that's right. I would say, like, the industry as a whole needs to be thinking about those challenges, but for the here and now, there's a whole raft of challenges that organizations are dealing with today, just around whether it's containerized workloads or even VM-based workloads running on something like EC2 or an Azure virtual machine that organizations need to think about. I mean, if you just take the new capabilities around automation, particularly automated infrastructure provisioning, when you start thinking about infrastructure as code, when you think about things like auto scaling groups, even for VM-based workloads and applications, at the point that you can mushroom out your server farm from say dozens or handfuls to thousands or tens of thousands of VMs. Now, what are the implications of that for your attack surface? What are the implications of that for data governance, for your internal security controls? And so, while serverless is definitely something that folks should be thinking about and planning for, I think the more pressing and more immediate needs are around how to sort of organize the chaos and ensure that audit trails exist, ensure that observability is really a requirement that's built in at the design phase, for whether it's a migration or for an architecture discussion versus something that's an afterthought or bolted on after the fact.
Jeff, when we look at network traffic analysis in the cloud, is it easier to achieve if I'm doing infrastructure as a service in like an EC2 or other cloud provider? And then, like, what are the challenges as you make that migration? Maybe you've got containers, maybe you're utilizing services and serverless in the cloud.
Yeah, good question. So, IaaS is really the low-hanging fruit for network visibility. And the reason for that is simple. The cloud service providers have either already shipped or have made available or are planning on making available some kind of native network traffic mirroring capability. So in Amazon's case, this is the VPC traffic mirroring capability. Azure has announced a virtual network tap, and GCP has made available a packet mirroring capability as well that's in preview. And so what this means is that organizations can apply a bit of config to, say, the network interface that's running on their IaaS VM,
right,
and have the cloud provider itself copy those packets and send them to an analysis tool. And so built into that conversation is this requirement to have a network interface that's tappable, right? And so that's where things like tapping traffic for something like a function, becomes difficult.
Right,
And
because the difference is in EC2 or however that looks in other cloud providers, it's like basically a virtual machine that has a network interface, and so that more easily transfers. So the transition into the cloud, there's no one standing up going, well, how do we get network, packet captures? It's pretty, you can wrap your brain around it because there's a network interface, right? But now where you're going is, what happens when you're using all these other services, right? Or however, whatever they are, they could be for containers, they could be for API gateways, whatever. How do you get that traffic?
Sure. Yeah, and today, it's actually not possible. So if you've got a function, it doesn't have an interface. Now we know that Lambda functions do have an elastic network interface, but today it's not possible to include those in a VPC traffic mirroring session.
Interesting.
So that's something that we'd be looking to Amazon to add at some point in the future, but it's not available today. I think it's worth taking a step back though, before to really look at why the cloud service providers have made this capability available in the first place. So in other words, why packet analysis as a way of getting observability into cloud workloads? This is kind of an interesting question, right? Cloud service providers already provide a number of different native capabilities for getting observability. And if you think about it, all of them in some form or fashion boil down to streaming events that are captured in logs and then stored and then parsed and analyzed, where then in some cases, machine learning algorithms or human analysts can comb over that data set and surface alerts and trigger automated remediation or automated corrective action. And this could be, from an InfoSec standpoint, say from automating the different parts of the incident response playbook, or even from a service delivery standpoint to say automatically trigger an auto scaling event to add capacity where needed and things like that. But at the end of the day, all of the native capabilities that cloud service providers are offering have to do with first getting some logs stored centrally so they can be analyzed. And so why, it's a natural question to ask, why packets, right? And one of the things that we've found, and anyone that's been in the space for a significant amount of time will realize, cloud service providers don't offer any native capability for packet analysis. And in fact, they're very explicit about this to the point of drilling it into you as you prepare for your certification exams, for instance. You might see questions that allude to a need to set up some intrusion detection or intrusion prevention system, and you might be asked, what native tools would you use to do this? And it turns out that the answer is none of the above, right? Go to the marketplace, find a third-party solution. And so cloud providers have been explicit about not offering that capability themselves, but they've also, as I mentioned a minute ago, have introduced native cloud packet mirroring capabilities to really smooth the path of packet acquisition for the third-party tools in their technology ecosystems. And so why is that? And I think what we're seeing is the answer has to do with quality and speed to detect faults and robustness of response that's enabled by that early detection. So I want to unpack both of those for a moment, if I could. So if you think about making this paradigm shift from protect and prevent, whether we're talking about service availability and preventing outages, or if we're talking about information security incidents and breaches and compromise, I think the world has, by and large, transitioned from this notion of let's prevent breaches or prevent outages and assume that they're actually inevitable, and shift our attention and our focus to how to recover quickly. And that's really the new sort of accepted way of thinking about resiliency is quick recovery. And so quick recovery obviously requires robust early warning systems. And so it turns out that one of the Achilles heels of streaming event data to log collection systems is this minutes latency that can be experienced. So
also, I think, and Jeff, correct me if I'm wrong, that logs in the cloud are probably even more problematic than they were when you were on premise, right? Because every service has to support some kind of logging functionality. The central logging facility that you've chosen then has to support whatever logs those services are spitting out. Like in AWS, I noticed you could link to a Splunk instance or whatever. There's lots of ways to collect logs. It seems to me like there's a lot of points of failure in there as to the level of logging, how you configure logging in all of the ways in which you can deploy something into the cloud, correct?
Yeah, that's I mean, all of that baggage around log collection and analysis exists in the on-prem world as well, right? So there's a lot of options. There are certainly some best practices, but at the end of the day, it's pretty onerous to set up a log collection regime that is dynamic and sort of intelligent enough to keep pace with changing infrastructure. So, and this is true in the data center world as well, right? So VMs spin up, they spin down, they vMotion across a data center, and log forwarders can get shut off. They can get disabled, certainly by an adversary in the event of an instance or a VM compromise. And so, there's this great irony that exists where not only are logs difficult to procure in the first place, but typically at the moment that you need them the most, they're often not there.
Right.
And that's either because they've been disabled maliciously or because it's too cost prohibitive to say log every interaction with the database table that might contain your regulated data, your customer data, your PII data, the crown jewels that you're charged with protecting.
Right. Yeah, because then you're charged for storage of said logs, and you're charged for access of said logs, whether it's in or out. Or
because in the cloud provider, data in's free, data out costs you money, right? So not only do you have to store those logs, now you have to extract those logs out potentially to analyze them. There's a big cost component.
And here's the other vulnerability that I think is kind of an overarching exposure for many different cloud services. The Black Hills team provided a specific example where either you as the user are trying to spin something new up in the cloud, or as the elasticity of the cloud allows for new things to be created automatically, those defaults when things are getting created, like if you've ever gone to AWS and just use the Get Starting guide, it creates a whole bunch of stuff for you. So you don't have to worry about VPCs or blogging or any of that stuff, but it's using the default method. So if something new spins up in your cloud, it may not be configured to go to your central logging place. That's why I like having the network visibility, because even in the cloud, the network doesn't lie. Right? And you understand where there might be some limitations on that. I still think it's better than logs. I still think it's better than trying to put an endpoint agent on everything you're deploying in, because that falls down somewhat when you get to serverless as well.
Yeah, and I think that's a really good point. I mean, particularly, we're seeing with organizations that are on their way to the cloud, that are in the middle of a migration, a lot of them are suffering from this affliction we refer to as the great stall, where you get some workloads migrated, some VMs migrated, but then a lot of times it'll be the InfoSec team actually will come in and say, well, wait a minute, we got to pump the brakes here. We are moving these workloads, we're spinning stuff up in the cloud. This is the Wild West. We don't have our arms around it. We're not able to enforce our data access policies, our data usage policies, our data retention policies,
identity management
compliance implications, right? Our identity management policies. So we really need to put the pump the brakes on the initiative to migrate to the cloud. And this is problematic for the business, right? Because let's say the business has already understood and bought into the notion that cloud is going to be the great enabler. It's going to be the thing that finally lets IT fulfill the promise that it's been making to the business for years of making the business more competitive and things like that. And so to have that kind of an initiative come to a screeching halt until security can kind of catch up and ramp up on what the attack surface is now looking like or about to look like, it's a real problem. And so, when we talk about the inability to install an EDR agent, or the fact that new workloads might come into existence that will never be on the radar, is a real problem for security. So I was actually working with a customer here in the Seattle area recently. Wizards of the Coast is a gaming development company, and they were coming to grips with this tension between giving security the visibility that's needed to protect the estate while not standing in the way of developer productivity, right? And so another sort of piece of baggage around installing an endpoint agent is this has to be vetted, right? It actually ends up being a gate to developers deploying infrastructure, redeploying workloads. And so security is in this really tough spot. When they implemented ExtraHop, what they found was leveraging the network as a source of data, right? By analyzing data in flight, security could have that early detection and automated response system and capability without imposing any constraints or any burdens on their developers.
Yeah, one of the challenges always in the cloud has been lack of visibility and control. And so we try to do that with endpoints, but to your point, when you think about these architectures and the need to embed agents on in these different microservices, that doesn't really scale very well. If you can provide
That's right.
ease of visibility and control at the network layer and give them those same capabilities at the network layer versus the endpoint layer, there's less friction for the development teams, because now they don't have to worry about, well, is that agent going to impact the performance of my application, or is it going to cause something else to happen in the app that we haven't tested for in our QA testing and all the other things that happen. This is it's an easier way to get that visibility and control. And now that the cloud providers have given us the ability to collect that data, it should make it hopefully a lot easier for security teams to get comfortable with that approach.
Yeah, that's exactly right. So using the network, and this is kind of getting back to this question of why did the cloud providers expose this native traffic mirroring capability to their third-party packet analyzer ecosystem? And this is exactly why. Because it really enables InfoSec teams to no longer be an obstacle to the cloud migration initiative. And so organizations can get past the great stall, right, and complete their cloud migration project with InfoSec, along with them. So because now InfoSec is no longer sacrificing visibility as that migration proceeds.
Yeah, I mean that's definitely a great approach, because we talk a lot about DevOps and all the things that have to happen in that environment, and slowing that train down is not in the best interest of the business, which usually leads to some level of getting the application out there without any visibility and control, just because it's got to get out there. So yeah, you don't want that great stall to happen.
Well, and you also don't want a different solution for on-premise, for AWS, for
And
Google,
Microsoft,
and for Microsoft, right? And it sounds like that's where ExtraHop is moving towards, is giving me that unified. Certainly today, I believe you can get great visibility in AWS and on-premise, and that all comes together in the same console in ExtraHop, correct?
Yeah, that's exactly right. So from a product perspective, for those that may not know, the ExtraHop system is an appliance-based technology. We also offer it as a SaaS service, but the core of the technology is an appliance-based. So if customers want to manage these appliances themselves, they can deploy them wherever their workloads live. So any cloud provider, or certainly on premises, or in data centers, or in branch offices.
Right. It's that centralization that's important, because to your point, Paul, right?
Yeah.
We're going to see customers in a hybrid, in a multi-cloud environment. And I don't want to, because we'll end up back in the SIM days in some respects, right? I'll have, all these disparate systems, and I got to figure out how to integrate all this data together to get me that early detection. If I can centralize all that, I streamline what those integration points look like at the network layer.
Well, and it's nice to do that at the network layer too, because log formats are all over the place. At least with TCP/IP, there's some standardization. Right?
A packet is a packet is a packet.
Well, I mean, everyone has their interpretation of RFCs and different protocols, right? And that's largely what ExtraHop is helping you with as well. But there's more of a standard, right? Which is why I really like that, to have that in my arsenal and to be able to unify that. I think is really important.
I think that's a fantastic point. I mean, so what you're alluding to is really one of the most painful parts of doing log analysis, which is that normalization phase. So when you're doing some kind of ETL operation just to normalize the data so that it can be analyzed or say correlated across different log sources, it's really difficult. And so, one of the advantages that you have when doing network traffic analysis is network protocols, whether they're application layer protocols, like say for a different database flavors, or transport protocols like TCP, they're very well defined. And so there's really no need for, to normalize across different sources. If something's talking TCP or if something's talking, say HTTP or DNS, it doesn't matter what it is, right? It all looks the same on the wire.
Yeah, we get out of the you said ETL. I used to call it ELT in the big data days, right? You extract, load, then you do all your transformations to do the normalization. You skip some of you streamline some of those steps at the network layer where things are more consistent.
Yeah, that's exactly right.
Yeah.
Awesome. So now let's talk about, as we round up this segment, Jeff, the customers that you're working with, obviously you don't have to name them, that are really advanced on the cloud front and how they might be using ExtraHop.
Yeah, sure. So I mentioned Wizards of the Coast a moment ago. I can continue that story a bit. So the folks at Wizards are doing some really interesting things. So they're obviously in a very competitive landscape. So as a content producer, as a game publisher, they know that if they're not creating compelling content for their users, it's very easy for users to pick up a game from one of their competitors. And so what enables them to attract and retain subscribers is really their ability to produce quality content quickly. And so how do you know what's going to stick? Well, the key to that is really experimentation. And so Wizards is able to leverage the cloud and to essentially conduct business experiments and publish new games, understand what's gonna have market uptake, and double down on those bets. And for the things that don't stick, they can move on and conduct another experiment. And so cloud is really an enabler for the business in Wizards' case. And it's, of course, things like Magic the Gathering Arena and Magic the Gathering Online and other titles that they've got for a variety of different platforms. And so when you've got a number of different titles, a number of different types of content, think about what your attack surface looks like. Now, if you're trying to protect your intellectual property in terms of media and storylines, but also ensure that users of the game are not able to, say, cheat at the game.
Right.
And so really protecting the experience of the player and ensuring there's no reputational impact to Wizards, right? Again, which might trigger some attrition or cause some retention issues. And so all of those considerations are on the table for the InfoSec team, and it's really around securing that estate without getting in the way or hampering developer productivity. And so having a frictionless way of getting situational awareness by leveraging the network is a huge win for Wizards. I'll mention the other thing that was valuable for the Wizards folks, and that's this notion of using empirical data to drive decision making and drive response efforts. So a contrast that I'll draw is with doing something like vulnerability management, which is obviously a critical sort of foundational practice for any InfoSec organization. But if you have to think about it maybe differently in the cloud. So if you've got ephemeral workloads who have a lifespan of minutes or days versus months or years, you're going to think about patch management differently. And if your work queue is being filled with a bunch of notices of, what workloads are missing what patches, it ends up not being super actionable. And so when you're looking at real-time detection capability of, say, CVEs that are actively being exploited right now, your focus can shift to have your analysts attend to and triage those things which are actually threatening your critical assets and your business operations versus, say, responding to hypothetical risks that in reality have a very low likelihood or maybe even a zero likelihood of actually transpiring.
That's a great analogy because Paul and I have a lot of experience in the vulnerability management space. Mm-hmm. It's difficult, I think, to do effectively in the cloud because, like Jeff said, things are coming up and down all the time.
Yep.
You're constantly pushing new releases out. I think one of the most extreme cases I saw was Etsy pushing a release every 7 minutes. Think about that from a vulnerability scanning perspective for a second.
It has to be done before you push the infrastructure out.
Exactly. But how many people are scanning that quickly in their environment? I talk about this frequency issue in security. We scan our networks maybe once a month, once a week. We're not scanning our network every 7 minutes. How are you going to catch those? And so if you're trying to enable a business to be very dynamic and flexible in the cloud, a vulnerability management program doesn't really give you a lot of benefits. It potentially slows things down, but if you can...
Well, the scanning aspect doesn't.
Yeah, well, potentially. It depends. Again, back to this agent. I could have an agent, I guess, installed in the environment, and it's doing it in real time.
It's more composition analysis.
Yes.
Where I think of vulnerability management playing into your
scenario. Kind of the scanning side, right? And so real-time detection capabilities, I think, are needed and have an advantage in the cloud just because of the dynamic nature of the cloud, where some of these more traditional, kind of more, I wouldn't say static, but just they don't have that high frequency to them necessarily, can struggle in the cloud. So I think it's a great analogy because we see that a lot. We saw that a lot when we were at Tenable together. And so, yeah, something different that really can detect what CVEs are being compromised right now that drive prioritization for response versus here's my list of vulnerabilities and patches that need to be applied because it's going to change
right.
often.
That's awesome. We do have ExtraHop customer coming on next week. Yeah, next week, talking about their experiences with the product. As always, our listeners can visit securityweekly.com/ExtraHop and register for a demo. And Jeff, your story about the Wizards company is at extrahop.com/wizards. I think it was a full presentation that they gave, correct?
Yeah, actually, Wizards took the stage at reInvent this year, speaking about how they were using VPC traffic mirroring to seamlessly take advantage of ExtraHop's network detection and response capability so that InfoSec can secure the estate, but without standing in the way of developer productivity.
Fantastic.
That's awesome.
Jeff, thank you so much for appearing on Enterprise Security Weekly.
Yeah, it's good to be here. And I'll encourage folks to visit our booth at RSA if you want to learn more about ExtraHop or about how, say, our other customers are securing their cloud workloads.
Fantastic. Thank you so much. With that will conclude this episode of Enterprise Security Weekly. Thank you, everyone, for listening and watching. We'll see you next time.